Well, good afternoon and welcome to another edition of our Lunch and Learn here at Tellus Science Museum. I'm David Dundee. I'm Director of Education. I'm so glad you've taken time out of your busy day to come join us here at the museum. As always, I want to thank our sponsors, Century 21 of Cartersville, for their support, and also Century Bank for their support here at the museum. Wanted to tell you about some things coming up. This Friday night, Dr. Tracy Scott will be with us doing a talk, and she is an Emory professor, not an astronomer. She's actually in the psychology department, but she is writing a book, and she's been interviewing families of Apollo astronauts. And she has stories about the impact of the space program, the moon program in particular, on these families. And so it'll be kind of an interesting talk to hear the human side of the moon program. Speaking of things coming up, if you're into launching rockets, ages 8 and up, we have a Build and Blast workshop coming up on February the 10th. You can come here, build your rocket, and while the glue is drying, we have a NASA ambassador to tell you all about the latest NASA rockets, and then we go outside and launch your rockets, and you get to take them home with you after that, so that's pretty cool. And on February 17th, coming up, we have Dinosaur Day. Dino Day is coming here to the museum, a whole day devoted to dinosaurs. We have cool interactive activities. We have some live dinosaurs here. Well, actually, people in dinosaur costumes. But they're doing some dinosaur shows here at the museum. It should be great fun, so please come and enjoy that. If you're into looking through our telescope, we have a solar sky watch coming up on February 3rd. That's Saturday. If the weather's clear, you have to bring clear weather with you. We'll have the telescope open to look at the sun safely, and the sun is pretty active right now, so lots of things going on the sun. So for today, we have our own Tellus Astronomer Karisa Zdanky here today to tell us how to use your telescope. In case you've gotten a telescope recently, perhaps one over the holidays, and are wondering what to do and how to set it up, Karisa will have all the answers for you in her talk today. So please welcome Karisa to the stage. Yay!
All right, thank you for the introduction, David. And I mean, with that, I might as well just get right into it. So one of the most important things with how to use a telescope, I know you're going to hate to hear this, it is to read the manual. So the manual actually has a lot of really useful information, just such as the telescope anatomy, specifications for your exact telescope, and also maintenance instructions. So if you don't have one, maybe you got a used one, the type of telescope that you have should be written on it somewhere. Look it up. You can find a lot of these PDFs just online. And once you have that and you put your telescope together, really spend a day just to familiarize yourself with the telescope itself and the controls. So for example, locking and focusing probably is not going to come natural to you if you've never used a telescope before. So speaking of the telescope anatomy, I will be referencing these a few times during my talk. So I will explain some of the basic ones to you. The main part that you think of when you think of a telescope, that is the optical tube. That's where the light is going from the top to the bottom to your eye. We've also got the finder scope. That is a really small, low magnification telescope that is close to where you look in it, so it gives you a general view of what you may be able to see in your telescope. The eyepiece, that is what you are actually going to be looking into. The star diagonal, I'm not referencing that one, but all that does is really just bend the image so it's not coming straight down the bottom of the telescope, so it's actually going up into your eye. We've also got the focuser, so what that does is if your image is blurry, you're going to turn that knob a little bit and it will make it nice and clear. And that tends to either be a knob it's kind of hard to see, but like the one in this picture where you're turning it towards or away from you, or it could potentially be on the telescope pointing out and you turn it clockwise or counterclockwise. We also have the mount, that is what is holding the telescope, and that is what you are going to turn to change what you're looking at. And then we've also got the tripod, that's what you adjust to make sure your telescope is level on the ground. And you most likely, well, you do have one of these two types of mounts. So there is an alt-az mount, and there's also an equatorial mount. So alt-az mounts are the most common, and they allow you to move the telescope left and right, and also up and down. And so what that is, the up and down, that's going along the altitude, and then the left and right, that's the azimuth, so that is the number of degrees that you are away from north. Equatorial mounts don't move in straight lines like that. They were actually designed to track the stars. And so that's why it turns around the celestial pole. That's towards the right ascension. And then up and down away from that is the declination. And what those are actually star coordinates. So they correlate directly with longitude and latitude. So RA goes north to south with the longitude, and the declination goes east to west with the latitude. And every star and object in space does have its own point. So Sirius is going to have its own specific RA and dec that you could potentially input into your finder. Also back to here, basically to move your telescope, there's going to be two little levers or knobs, and those will be lock knobs. So you want to loosen those, gently grab the optical tube, point it towards your next object, and then you're going to relock the telescope. And there should also be a slow motion control knob. You can see one on the equatorial mount, the one where the arrow that says to Polaris/celestial poles on top of. If you turn that, all that does, that's for finer adjustments if you're trying to center an object. A lot of newer telescopes will also have a hand controller that will take you directly to the object. You do have to align those the first time you use them, and the easiest way to do that is called a two-star alignment, but that does involve you knowing two stars in the sky and being able to point the telescope to that. But we'll get to that, to knowing your sky later. Now, once you have moved your telescope, the next thing you would want to do is put in an eyepiece. Choosing an eyepiece can be definitely overwhelming. There is a ton here. There's different brands, that all have different numbers on them, but the numbers are important. And if you want a specific magnification, you're going to have to do a little bit of math. This is my only slide with math on it, I promise. Before I get into these, one of the biggest questions that people ask me in the observatory is, what's the magnification of our telescope? And I always say, magnification is not as important as you think it is. What's more important is the aperture, or also the diameter of your telescope. So that's going to be the number that's on the box. And so the bigger the aperture, the more light you let in, the more dimmer objects you are able to observe. Magnification, what that more does is, it just really is how big your object looks to you through the eyepiece. So the general equation for magnification is the focal length of the telescope over the focal length of the eyepiece. And what the focal length is the distance between the primary lens or mirror, depending on what type of telescope you have, to where the light rays come together and focus near your eye. And you don't have to do any math or anything like that to find that out. The focal length of the telescope will be written in the manual or sometimes on the telescope itself. And the focal length of the eyepiece is written on the eyepiece. So actually, if you see in some of the green ones, it's easiest, like there's a 17 on that one and a 6 on that one. Those are the focal lengths of those two eyepieces. So the optimal magnification, it's a general equation. So what you're going to do for that one is the aperture in millimeters over 0.7. So for example, if you have a 90 millimeter telescope, you do 90 divided by 0.7, you're going to want to be aiming for about 128 times magnification. And like I said, it's a general equation. Feel free to absolutely mix it up depending on what you're looking at. That's just what typically works. And the maximum magnification, you should not have to go over this number, is the aperture in millimeters times 2. So if you plug that in, I wouldn't go for a eyepiece that makes your magnification more than that number. So once you've picked out your eyepiece, you may not have your finder scope on, so you have to attach and also align it to make sure that it helps you to find objects in the night sky. It will probably explain what specific finder you have in the manual, but in general, there's going to be that bracket there, and they tend to either have knobs on the side, like this one, or a little screw that suspends the finder in that bracket. So to completely align it, you want to choose the lowest magnification eyepiece you have, so that's going to be the eyepiece with the biggest number on it. Then just find an object that you know how to find, and put it in the view of the main telescope, and then tighten the lock knobs to keep that optical tube in place. Then you want to center that object in the finder scope, then increase your magnification, so get a lower number, yes, get a lower number, and then just repeat until you get to the largest magnification and your object is still in the middle. Lastly, before we move on to specific viewing, we have to talk about how to look through a telescope. This kid is actually doing it the right way. As you can see, he's looking straight down the tube. A lot of people, surprisingly, have issues with that, but it's really important that you're looking straight down it, or else that image is not going to hit your eye correctly. And also, as you can see, he's holding one hand over his eye. I always tell people, if you take 2 hands, put one hand on your eye and one hand on your thigh, so that way you are not touching the telescope. Because if you jostle that eyepiece a little bit, it can make it, you can lose the object that you're trying to see, and also if it happens often, you can weaken the lock knobs when you eventually have to replace those. And especially if you've spent all that time, if you spend all that time trying to find an object, you may get a little annoyed if you have to keep on finding it every 5 minutes because your telescope keeps on losing the object. So day viewing, people don't realize this, the stereotypical telescope is out at night, but you can also use your telescope to look at the sun during the day, and it is one of my favorite things to do. But there's a very important accessory that you need for that, and that is called a solar filter. And the point of a solar filter is it protects your eyes from the sun. This actually blocks out 99.999% of the light. So I like to say it's like giving your telescope a welding mask so that it's able to look at it safely. Before you put it on your telescope, you want to make sure that there are no scratches or pinholes in it. So the best way to do that is to take your phone flashlight and hold it under the filter, or hold it up to the sky, away from the sun, to make sure that none of the light is shining through. If you find any, it's a lost cause. It can really hurt your eyes if you do look through a damaged solar filter. So just toss it and buy a new one if any of that light comes through. And once you're sure that your solar filter is good to use, all you do is you just place it on the top of your telescope. When you buy them, you do have to make sure that they're the right size. So ones like this, without any knobs on the side, should fit snugly around the top of your telescope. Sometimes they do have knobs on the side. If they have those, you just want to twist that so that it's finger tight. You don't want to dent the top of the telescope at all. Then once you have your solar filter on, you can actually start to try to find the sun. And it's kind of counterintuitive. You would think you're looking through the telescope to find the object, but you actually want to look at the shadow on the ground to find the sun. So look at the ground, try to align the telescope so that its shadow is as small, round as possible. You want it ideally to be crisp. This way, the angle is going straight into the telescope, and it's making that perfect circle, ideally. And once you think you have it, you can go ahead and look through. Sometimes you don't always get it the first time. I've taken 10, 15 minutes just trying to go back and forth and trying to get the sun. But if you can't see it at first, you feel free to move it around a little bit, and if you see any light along the edges of that eyepiece, chase it, because the sun is really close. So this is what the sun looks like during a typical day to us, but that view with a solar filter on makes it look like this. And so this is the photosphere, the surface of the sun, as much of a surface as a ball of gas can have. And this view also allows us to see sunspots. The sun has a very strong magnetic field that stretches even outside of the solar system, and sunspots are those areas on the sun where the magnetic field is particularly strong and they're also cooler. So instead of 10,000 degrees Fahrenheit like the surface of the sun, it's about 7,000 degrees Fahrenheit. So now, night viewing. Before we actually get outside, you have to check the weather. A lot of people ask us, it's cloudy. Are you still open? Can you still see anything? No, we cannot. I get the confusion. If it's cloudy, the James Webb Space Telescope doesn't matter if it's cloudy at all. But on Earth, with a visual telescope, the clouds, if they're in the way, we cannot see anything. So if it's cloudy, you're not going to be able to observe. And believe it or not, the moon phase can also affect your viewing. So it sort of acts as, technically the moon does not count as light pollution, but for viewing through a telescope, it's sort of like a natural light pollution, so it can make it harder to find dim objects in the sky. So ideally, you would want to do your observing when the moon is closer to a new moon, or if it's not above the horizon yet. Obviously, if your goal is to view the moon, that's a completely different story. Aim for whichever moon phase you want to aim, if that's what you're going for. And this is just an example of how it really matters. These are two different images of the Orion Nebula. So the one on the left is from a full moon with a bit of haze, but you can't really see a lot of those stars. It's just, you can see the basics, that's about it. With the new moon, you can get a lot of those dimmer objects. Also, what you want to check for is how the stars themselves look. If all of your stars are twinkling, like in this picture, your atmosphere is not great that night. You may have some poor seeing. When you look through it, it may be a bit wobbly in your view. The atmosphere, it does alter your image. So ideally, you want all of your stars to look steady, almost to the horizon. And for the same reason, it's actually a lot better to observe in the winter over the summer. You can still do it, but it's going to be really hot, which also isn't the best for your telescope. It's more humid. There's cooler stuff in winter anyway. I like it. Also, what is really important is that you are not wearing white headlamps. I can tell that this is not a group of astronomers because they're all wearing white headlamps. Astronomers and stargazers will all be wearing red headlamps and have red lights with them. This is actually because it ruins your night vision. So in your retina, there are two types of cells called rod cells and cone cells. And what cone cells do is they allow you to see color. But what rod cells do is used to perceive black and white in lower light levels. However, the rod cells don't actually work on their own. They require a chemical that the body produces called rhodopsin. And our body only produces that chemical after about 20 minutes in low light levels. So rhodopsin is also photoreactive, which means that it has a chemical reaction caused by bright light. So in this case, any bright light causes that rhodopsin to quickly decay, and your night vision basically gets reset, and you have to wait for the 20 minutes again for your body to produce that chemical. So unless you want to take twice as much time just to be able to see some stuff, I really recommend sticking with the red. And this is actually also why the moon, since the moon reflects white light, it can also ruin your night vision on a new moon, full moon, sorry. And what also astronomers do when they look through telescopes is use their averted vision. So what this means is it's basically you are not looking at an object, you are looking near an object because you can see more light and see more detail out of your peripheral vision. So I'll let you try it with this one. If you want to just close one eye and look at one of the black dots next to the object in the middle. This is the graphic I 100% stole from NASA, so it's from NASA. Give you a few seconds. See if that does anything. Also, on a screen, it is kind of hard, especially with this white background. So if you couldn't see it, or if it was too easy, this is a little bit closer to what you would actually be seeing through a telescope. So I'll give you a few seconds. Try and do the same thing. So don't look in the middle, look around the edges. And also, there are two things in the middle. So if you can see them, they'll look fuzzy. These are two galaxies called M81 and M82. So that is the Cigar Galaxy and Bode's Galaxy. And if you've seen them, they are right here. So not sure if you were able to see those. Again, this is on a screen in a light room. This works a lot better when you're actually looking through a telescope on a dark night. So one thing that is also very important when you're doing night observing is to have a star chart or a website that you use or an app that you use. It really helps to familiarize yourself with the night sky. It's going to help you so much to find objects quickly. So this is my preferred one. This is a program called Stellarium. Shameless plug, it's totally free. I highly recommend it. But even on here, you can see constellations, you can see specific objects, like we've got M47, I think, right there. So there's a lot of cool things that you're able to do. Also, you can't see objects all the time, so maybe if there's a favorite object of yours, you really do want to check on a website or an app like this to make sure that it's even up right now, since the night sky is seasonal. There are winter, summer, constellations, etc., and those objects also do not move from our perspective, so they are also seasonal. Also, you should really know how bright your object is. And in astronomy, that is a number called magnitude, or apparent magnitude. So in this case, it's like golf. So the lower the number, the brighter an object is. So we've got the sun at negative 26.7, and we've got the faintest objects observable by the Hubble telescope at 30. There are certain objects, from here we can see about an 8 to 8 on a good night, but depending on how big your telescope is, you may want to aim for some of those lower number objects. So for example, this is the constellation Lyra, which is a summer constellation, and on the opposite side of the constellation from Vega, you can actually see that there's an object there called M57. It's the ring nebula. It's a magnitude of 8.8. On a good night, we can see that one from here. And if you know where this object is, it really does help you to be able to find it quickly. So this one in particular is almost directly in between those two stars on the opposite end of Vega. So, I mean, even I've had to do this one time. A friend and I rented a telescope, went somewhere rural in Wyoming, and we were just looking at stuff, and I probably found this object in 2 minutes because I was able to just go straight there. Versus if I didn't know exactly where it was, it would have taken me probably 20 minutes just to find out precisely where it was. So if you do know that, it will really give you a major advantage. And I've mentioned M objects a few times. A lot of these are really good like starting locations to look for. And what the M stands for is Messier. There's 110 Messier objects cataloged by the French astronomer Charles Messier when he was attempting to find comets. It was really funny, actually, because he kept on getting annoyed that he was finding these because he just wanted to find comets. So he was keeping a catalog so that if he saw them again, he would know what they were. And everybody else uses them now. And depending on your sky, these are all objects that can be seen with the naked eye. So some of my favorites on this list are M42, which is the Orion Nebula, M31, which is the Andromeda Galaxy, and M13, which is the Hercules Cluster. So if these are things that you want to look for, definitely check out the magnitude of these objects and see if your telescope is able to pick them up. Once you are done observing for the evening, it's time to store your telescope. The best way to do it is to be preventative. So you always want to keep your caps on as best you can. You want to avoid dust getting into the optical tube of your telescope. A little bit of dust isn't going to hurt, but build up over time, it will affect how you see your objects. So if you have lost your cap for some reason, use anything. Use a shower cap, just something to put there to keep the dust from getting inside. And they also have caps for the eyepieces on the top and the bottom. Sometimes it's a tube. And they'll also give you a cap for where the eyepiece slots into place in the telescope itself. So you just want to, as best you can, avoid any dust getting inside. Also, as you can see here, it is good to get a cover. So even with the caps on, you can buy a cover. They're relatively cheap compared to the cost of a telescope. I think this one I pulled from Amazon was like $35, something like that. So not too awful. If for some reason you have forgotten to put on the cover or you left a cap off and dust does get in, I would say the best way to start cleaning it is by using compressed air, because you don't want to leave streaks on the mirror or lens of your telescope, and that just helps it stay clean. Anything more than that, it would involve kind of taking the telescope apart to make sure you can actually reach the mirror. So those are the basics. Hopefully in the last half hour you've learned a little bit something about how to set up your telescope, how to look through a telescope, and I think we're good to open up for questions.
And if you have a question, just raise your hand. Since we're recording this and broadcasting it, I will bring the microphone to you. So if you have a question, I see a brave listener out here.
What is your favorite part of looking at the moon? Is it the craters? Is it the light spots? Is it like, what is your favorite part of looking at the moon?
This is going to be a very specific answer. So my favorite part of looking at the moon is actually the line where the light side meets the dark side is called the terminator. And on that line, you can actually kind of see into the depths of these craters. It's a really cool view. I highly recommend pointing your telescope at the moon and looking at the terminator.
Oh, another question. Looks like trouble over here.
You said you use a solar filter to protect your eyes. Does it hurt the telescope to look at the sun or to point at the sun without a filter on it?
Yes, it does.
What happens?
Well, you could melt it a little bit. So I don't know if you've ever seen, like if people hold a little magnifying glass up in sunlight, you can actually like burn the ground below it. You're doing that, except it's way stronger because the telescope has more power than a magnifying glass. So it would not go well.
Other questions? Oh, I see a hand up front.
Can you use the M coordinates to find something, or if you've got one of the automated systems, can you punch that in and find a particular star or galaxy without having to go through the whole process of...
Yes, so you're saying if you have like one of the automated hand controls? Right. Yeah, so you wouldn't have to really try to find and learn exactly where the objects are. It would be nice to do, but with something like that, you pretty much just have to do that initial alignment, which that's the 2-star alignment that I mentioned earlier, and then after that, it should have a list of objects, and you just scroll through them, click one, hit go to, and it should go straight there. You may have to do some slight adjustments if it's off, but easier.
Okay, do we have a question back over here? You have a question?
Two questions. Who was the first person that made the first telescope, and when?
Well, I know I think it's Galileo. Was a pioneer in telescopes. Oh, I do not know the exact year. Sometime in the 1600s.
And come over here to the front.
Can you see any of the galaxies with your naked eye?
Yes, so the Andromeda galaxy you can see with the naked eye. That one, it's our closest neighbor in the galaxy-wise. It's going to really look like a piece of fuzz to you, though. So it's going to look pretty similar to that. And I think the screenshot that I took, you can see the exact, yeah. So the Andromeda Galaxy is right there on that view.
All right, we got a question back over here.
So is there any way for me to attach cameras to my telescope, and how would I do that?
Oh, yes. So depends what type of camera you're trying to attach. They do sell cameras, like we've got one called a ZWO camera. That one, it just replaces the eyepiece. So you put it in, you can take pictures that way. If you're talking about attaching an actual camera to the back of a telescope, there's mounts for that. And even if you're talking about just a cell phone, they make smartphone mounts to attach your phone so that it's looking through the eyepiece.
Yeah, imaging has come a long way in astronomy, and there's actually a whole generation of imaging telescopes that you can set up, and it instantly takes pictures for you. It's kind of amazing.
There was a star called Betelgeuse that just exploded 100-something years ago. Did the explosion already pass Earth?
So Betelgeuse, they're actually not sure if it's blown up yet. They think it's due to. It's one of those things because, so the light from the sun is 8 light minutes old. So technically, if the sun disappeared in the last 8 minutes, we would not know about it. So it's the same thing with Betelgeuse. They think it may have blown up, but they're not 100% sure yet. So I also, luckily, have a picture of Betelgeuse in here. So that's this one. That's this star on the top and this one over here. Those are Betelgeuse. So to us, it still just looks like a red star in the sky.
Oh. Well, Chris will be around to answer more questions. We have some activities over here, some astronomy activities for our young astronomers that you can do. And let's have a big hand for Karisa.